Hi and welcome to video 4. In video 4 we're going to look at the matrices of solving systems of linear equations. This will be the last video that I produce this week to support you in your preparation for exam block. So what I'm going to do is I'm going to look at the three different situations we could have with systems of linear equations, but through one matrix. So our matrix is 3a plus 2b minus c equals 0. Our second equation is a plus c equals 8, and our third equation is 4a plus 2b also equals 8. Now I know what you're thinking, how exciting, Mr. Manson's chosen to use a, b and c. Some extremely original and exciting variables. This might be quite boring. So our matrix in augmented form looks like this. 3, 2, negative 1, 1, 0, 1. Notice I've recognized the missing b variable there, which means it's 0b. 4, 2, 0, 0, 8, 8. Now, it's important to be thinking ahead about what types of solutions you're expecting to get. First of all, I have three relationships, 3 capital R, and 3 unknown variables. What could happen from here is, first of all, I might find that one of those variables cancels out very easily, and I'm quickly led towards a contradiction. And a contradiction will imply 0 solutions. On the other hand, this might solve out quite easily, and this would lead to 1 solution. And the third option is that I might find one relationship is cancelled, and this will lead to an infinite number of solutions. You will not get 2, 3, 4, 8, 15 or any other number of solutions apart from 0, 1 or an infinite number of solutions. Now we're going to see what happens in this particular example. So I'll start off with 3, 2, negative 1, 0, 1, 0, 1, 8, 4, 2, 0, 8, and I'm aiming to go from the original augmented matrix probably matrix to be better there, and from the original augmented matrix I will be heading towards Gaussian form by Gaussian elimination by using and I'll get to Gaussian form by which is another name for Gaussian form is row echelon form, and I use elementary row operations, and I want to get down to reduced row echelon form, which also will be elementary row operations, getting to there, and reduced row echelon form is by doing the Jordan elimination afterwards. So I'm going to start by doing some elementary row operations, aiming to get ones in the major diagonal. So the first thing I'm going to do is swap these rows. Swap row 1 and row 2, and I'll note that by doing an arrow and calling this row 1 and this one row 2. So my new matrix will look like this. 1, 0, 1, 8, 3, 2, negative 1, 0, 4, 2, 0, 8. Now I'm going to subtract 3 row 1s and subtract 4 row 1s from row 2 and 3. My new row 2, mind you. So 3 row 1s and 4 row 1s. My row 1 remains the same. my row 2 becomes 0, 2 because the 0 has no effect. Subtracting 3 1s from -1 is -4. Subtracting 3 8s from 0 is -24. 0, 2 remains the same here. Subtracting 4 1s from 0 is -4. Subtracting 4 8s from 8 is -24. Now I can already start to see a problem here. I'm going to divide the second row by 2. I need to get myself to a point where I can properly say that I have some sort of row cancellation. 1 0 1 8 0 1 -2 -12 0 2 -4 -24. Now you're probably thinking there is quicker ways of doing this, and perhaps there is. But in this case, I can already see, because row 2 and row 3 were the same, that I'm going to lose a relationship, which is going to give me an infinite number of solutions. And an infinite number of solutions relies on me going back and setting a parameter to show those infinite number of solutions in terms of that parameter. So I'm still going to have to follow through with this method. So the next thing I'll do now is I'll do my normal thing, which is to subtract 2 row 2s from row 3, because I have this 2 here. So my next matrix, augmented matrix, will be 1 0 1 8 0 1 -2 -12, and then 0 0 0 0. And at that point you recognize that row 3 is cancelled, which leaves you essentially with these two relationships: A plus C equals 8 and B minus 2C equals -12. Because we've got A on its own and B on its own, we're going to set C as our parameter. We could just simply leave C as it is, but the more common mathematical method here is to let C equal some given parameter. Often we use T. I don't know why. So we'll let C equal T, and now we get this situation: A plus T equals 8 and B minus 2T equals -12. Rearranging, we get this situation: A equals 8 minus T and B equals -12 plus 2T, and C equals T. And now for any T existing in the real numbers, these are our given A, B and C values. This is the situation with infinite solutions, and this is how we use the parameter to solve it. You've seen plenty of solutions, and there are examples in your textbook of single solution situations, and you have seen some solutions where you get a contradiction. If working with a problem that comes to a contradiction, ensure you get to the point where it's very clear that you can show that a certain variable, say x, is equal to 7 and 6 at the same time, which is where your contradiction lies. Other than that, you'll be working within context, given context, and developing your systems of linear equations and commenting on those systems of linear equations appropriately. On top of that, you may be asked to use inverses to solve your systems of linear equations, and I'll leave you to revise the inverses, as that involves the same process of augmented matrices, and there are examples in your book. Good luck revising.